Hey everyone, welcome back to the next session of insertion sorting. In this session, we are going to look at an example of insertion sort, and I am going to do a detailed sorting of an array, which is going to give you a very good understanding of how insertion sort sorts a list of integers. So let's dive into it. Here we have an array A with 5 integer values, and we are going to look at how insertion sorting is going to do the sorting of this array. So the first iteration starts with the second element. So if we talk about indexes, this is 0, 0th index, first index, second index, third index, and fourth index. And we will have I starting from the first index. And we are going to have j equal to I minus 1. Okay. And the third thing we are going to do is we are going to save the value at position I. Okay, fine. Now the j is going to decrement 1 at a time. So at this time, j is equal to 0. And we are going to increment j until either j becomes minus 1 or go past the array at the beginning, or the value at array j is less than value of k, or j is less than 0. This is the condition when we are going to break. Okay, so let's see. "31, 26, 55, 59, and 30. Okay, I is equal to 1, j is equal to 0, and k is equal to 26, which is array of I. Right? Now we are going to compare the value at jth index with value of k. And if value of k is smaller, we are going to move this value to the right. Okay, and going to overwrite the value to the right of j. So because value at j, which is 31, is greater than value of k, we are going to do a move. So our first iteration would be 31, 31. So we are actually doing a move and we are not doing a swap. Mind it. 55, 59, and 30. Okay. And at this iteration, After this iteration, j becomes 1 less, which means j equal to -1. So then this is our first iteration, or let's say this was our iteration 1.1. In 1.2, because j is -1, we are not going to do anything, and we are going to write k at array j plus 1, which is array of 0 is equal to k. This means we are going to write k here, and our array is going to look like, so k is 26, 31, 55, 59 and 30. Okay. Now let's go to the second iteration. In the second iteration, because in the previous iteration I was 1, I is going to be 2 and j is going to be 1 and k is going to be 55. Okay, let's see 2.1. So this is j, right? So we are going to compare this with this. So because 31 is smaller than 55, we are not going to do anything, right? So this iteration we won't do any changes in the array, and this will remain like this. Okay, fine. Let's go to the third iteration. I becomes 3, j becomes 2, okay, and k becomes 59. So we are going to compare the value at jth index with k, and because 59 is greater than 55, we won't do anything again, and our array after this iteration is going to remain same. Let's go to the final iteration. So I is equal to 4, j is equal to 3 and k is equal to 30, right? Let's compare. We are going to compare value at jth index with this. Because 30 is less than 59, what we are going to do is we are going to overwrite the value on the right of j, and we are going to get 59, 59, 55, 31, 26, and j is 1 minus, which means j becomes 2, and this is our second iteration. Okay, I is still here, k is still 30. So now compare this with this. 30 is smaller. This means this is going to move here and we are going to get 59, 55, 55, 31, 26, right? And then j will move one step less. J is equal to 1. I is still here and k is still 30. Let's do 4.3. So comparing value at this, which is 31, and this 30 is less than 31, which means this will move on the right. So 59, 55, 31, 31, 26, right? J will move here. I is still here. K is 30, right? Let's do 4.4. Comparing value at J, which is 26, and K is 30. Because 30 is greater than 26, we are not going to do anything. So when this iteration is going to end, we are going to write the value of K on J plus 1th index. So J is here, J plus 1 is this. Here we are going to write K, which is 30. 30, 31, 55, 59, 26. Fine. After that, in the next iteration, which is, because now we are done with J, the inner loop, we are going to increment I, and I will become 5, which is greater than the length. So the outer loop ends and the algorithm is finished, and we get the final sorting of our array using insertion sort. And this ends the sorting of this array. I hope this small example gave you a fairly better understanding of how insertion sort works. Maybe go through this example one more time and try to sort a couple of example arrays by yourself to get a in-depth knowledge of this algorithm. If you have questions or you don't understand any part, post in the comments and I will try to answer. I'm going to end this session here. Thanks for watching and bye for now.